Hey guys, welcome to Machine Learning Made Simple Part 2. I'm Amol Gyaneshwar and I'll be taking this lecture for today. We'll wait for a couple of minutes, we'll wait for everybody to join in and then we'll start. Meanwhile, if you have any doubts with the previous session we held on NumPy and Pandas, you can ask me in the comment section below and I'll be happy to help you out. So till the others are joining, I'll tell you a little bit about SIAM. SIAM stands for Society for Industrial and Applied Mathematics. It is an international chapter with a populace of more than 14,000 individuals across the globe. It has presence only in 5 colleges in the country, with VIT being the only private institution in this elite group. Our objective is to advance the application of mathematics and computational science to engineering, industry, science and society. But rest assured, math isn't all we do. We're a technical chapter and we'd like to dive into various domains like AI, ML, web dev, app dev, etc. And we aim to find technical solutions to real-world problems. So this was a little bit about SIAM. Before starting my lecture today, I would like to give a huge shout out to Shubham Bhaiya and SIAM for making this possible and giving me this platform to speak. So I'll tell you what we're going to be doing today. Now that we've finished learning about our data analysis libraries, it's actually time to start visualizing that data. We'll start off by learning about Matplotlib and then we'll move on to Seaborn for statistical plots. So let me introduce Matplotlib to you. Matplotlib basically is the grandfather library of data visualization with Python. It was created by John Hunter. He created it to replicate MATLAB. Now, if you have already coded in MATLAB in Mat 1001, you already must be familiar with it. So Matplotlib will feel natural to you. It's an excellent 2D and 3D graphics library for generating scientific figures. Some of the major pros of Matplotlib are generally easy to use to get started for simple plots, support for custom labels and texts, great control over every element in a figure, high quality output in many formats, JPG, PNG, etc. We'll see in the course. Very customizable in general. Matplotlib allows you to create a reproducible figures programmatically. So let's learn how to use it. Before we continue this lecture, I would encourage you to explore the official Matplotlib page. It's matplotlib.org. Okay, so before that, you'll have to install Matplotlib. In your command center, you could type in conda install Matplotlib or pip install Matplotlib depending on which command you're using. So I'll type it out for you. Conda install Matplotlib. And this is exactly what you're supposed to type, and this will do it. So if you remember from last time, the first thing which you do is you import your library or module. So we'll import Matplotlib under the name PLT. So we're going to import matplotlib dot pyplot as PLT. So we'll run that. Okay, so now you'll also need to use this line to see the plots in the notebook, which is matplotlib.inline. So now you run that. So basically this only works for Jupyter notebooks. If you're using another editor, you'll use plt.show, which is plt.show. At the end of all your plotting commands to have the figure pop up on another window. Otherwise, it won't. But if you're using Jupyter notebooks, percent matplotlib inline will do the same. So let's start with the basics. Now, before starting Matplotlib, Matplotlib allows you to quickly create a plot, and we'll show you in 2 ways. So first method is the functional method and the other one is the object-oriented method. We'll show the functional method first and then we shift over to the object-oriented method. That's the more used method in recent times. So you must be remembering from last time that we had our from the last lecture we had numpys and pandas, right? So in plotting a graph you need an x and a y. So I'm going to import numpy and I'm going to take in variables x and y so that we can plot this graph. So I already have that here. I'll just copy paste it so that we don't waste time on this. So basically what this is doing, it gives you an x value from 0 to 5 with 11 spacing. So if you want to, I'll show you x. This is how x looks, and from 0 to 5 you get 11 evenly spaced numbers. This is what linspace does, and y is just the square of x. So there you go. So now let's create a very simple plot using the following. I want to encourage you to use Shift Tab throughout the process to keep checking check out the document strings for each function we're using. So first things, let's plot our first graph. So we'll go with plt.plot and simply put in x and y. Now you see that gives you a very basic graph. Wonderful. So we've just seen how we make our first graph. Now let's say you want to change the color. You give in a color, let's say red. Now you get a red colored line. We'll see more on styles and colors later on in this video, but I just wanted to give you an example. And for very basic colors, it could also just take in R and you'll get the same output. So okay, now I remember I told you earlier that it's very easy to control the axis and the labels. So now how do you put a label to this? Remember how your physics teacher always cuts marks for things like not writing the label and what x-axis stands for and what y-axis stands for? Well, Matplotlib has got you covered. So over here, you need a very simple command. It's called plt.xlabel to put in the x label and plt.ylabel. And for title, it's plt.title. And that's very simple, and I have already copy pasted it. So let's not waste time on that. So here, and then I'm going to copy paste that, and there you go. So as you can see, I've written plt.xlabel. So x label comes here, x is axis title here, and then y title will come here, and then the string title here. So very simple up till now. So now let's go ahead and try something different. So now let's create multiplots on the same canvas. So now for that, what you need to do is you need to use subplot, plt.subplot. Mind you, we're still doing the functional method to plot a graph. So for that, now you'll see where the difference is between this and object-oriented plotting. So we're going to start with subplots. If you had to start, let's say we have to create two different plots. So we'll go with plt.subplot, and then for that, now you have to give number of rows, number of columns, and let's say 2, and then the plot number. So this is your first plot. Excuse me. So after that, now you are going to put in your what you want to plot in that subplot. You're going to plot that. So you're going to give in the function plt.plot, and let's say you want to plot x comma y with your line color being red. All right. So now this is red, and we're going to see more color options later on, but for now this is your basic. And I'll just see if I've copy pasted it here. Okay, no, I haven't copy pasted. So similarly, you'll have to do the same for plot number 2. So I'll just make a little edit here. Say now over here, remember as I had said, this was number of columns. Now next is number of number of rows. This 1 is for your number of rows, number of columns 2, and then plot number. So last time it was 1, so now this plot will be number 2. And let's say we want to plot, instead of x comma y, now we'll take y as the x variable and x as the y variable. So now this will be a different graph. And let's say color is green. So now let's run that and see how that looks. So it gives you, so now see, you've created multiple plots in the same canvas. There is one plot. This is how you would do in functional plotting. One plot you have x and y and red in color. Then the next is y and x and green in color. So this is functional plotting, and now let's move on to the more used method, the Matplotlib object-oriented method. So let me introduce what it is. Now that we've seen the basics, now let's break it down into more formal introduction of Matplotlib's oriented API. This means we'll instantiate figure objects and then call methods of attributes from that object. Sounds difficult? Definitely not. It's one of the simplest things you'll do, and you'll fall in love with it. Introduction. So now let's introduce you to this. The main idea in using more formal oriented object oriented method is to create figure objects and then just call methods or attributes of that object. This approach is nicer when dealing with a canvas that has multiple plots on it. To begin, we create a figure instance, then we can add axes to that. So okay, so let's create a figure. Let's create an empty plot. So we over here let's call fig, and we'll call this plt.plot. Sorry, plt.figure, my bad. And now we have to add axes to that. Axes is basically how you're going to be plotting your graph. It defines your graph. So I think I've already okay. So we're going to add axes. So the command for that is fig dot add axes underscore axes, and then we're going to put it in the brackets, and then here we go. And okay, so now in this bracket you're supposed to pass the list. So what you have to do is you have to pass in left, bottom, width, height of your graph. So first you have to put in, let's say, 0.1. All these values have to be from 0 to 1. So 0.1, and let's say width is 0.8 and height is 0.8. Great. So again, okay, I'll explain this again. So 0.1 is the left limit, bottom limit 0.1, width is 0.8, and height is 0.8. So, and all of these numbers will be between 0 and 1. All right. So now let's plot on that set of on this set of axes. So it is very simple. All you have to wait. I'll just copy paste to make it simpler. There you go. Okay, now I'll explain what I've done. So your first, now that you've created this figure, now you've added set of axes. So now on these axes you want to plot a plot which has x variable as x and y as y. You remember what our x and y was from here, right? So x is this is an array from 0 to 5, and then y is square of that, and y, and then we're going to set labels, similar instructions for setting the label, set x label, set y label, but instead of last time we just put in that. Now we have axes dot set label and set the title. So now let's run that and let's see what's the outcome. So great. So see, you get a nice graph here with x as your labels here, title is already there, and a red colored plot. This is exactly what was expected. Okay. So now in this, as you might have noticed, code is a little more complicated, but the advantage is that we have full control of where you want to plot axes, and axes, wherever axes are plotted, we have more control over that, and we can easily add more than one axis to the figure. So let's say we want to create two of them. Inside one we have to plot a plot, and last time we had plotted two different graphs. Now inside one of these plots if we had to plot, so let's go ahead and do that. Okay, so let's first create a we'll create a blank canvas and to start with. So we're starting with fig equal plt.figure. So now you'll understand what I mean by you can add more than one axis to the figure. So I'll try to explain this. So now you'll have, we'll say axis 1 equal to what we taken earlier. We'll take this one only. So axis 1 is fig dot add axis this, and now this is the main axis. Now we want to create another one inside the inside axis, right? So for that we'll take something similar, but we'll change the values. So you can go ahead and change values. So we want something smaller. Let's say I want left to be around 0.2, and you could take any value here. Actually, it doesn't really matter. Whatever values you choose, if you want to suggest any value. So okay, left, this is the leftmost value, so this goes, let's put it as 0.2. then bottom as again 0.2, and width and height, let's keep this as 0.4 and 0 this as 0.3. Actually, you know what, this will end up inside the graph, so we'll change to 0.5 so that it doesn't touch the graph. Yeah, okay, so now we're done with this. Okay, so now we'll have to add the axes, and now we'll have to plot the actual plot. So wait, I'll copy paste this particular line, copy paste it back here. So for axis 1, I'll add ones here. Now I'll explain what I've, as you must have noticed, now we're just setting them as x and y, and let's say we'll change the color this time, we'll call it blue. Now this is your x label, this is your y label, and this is your title. So we'll give it, actually we'll call it x1 so that you guys can see x1, and this is y1, and we'll call it title 1. So now you'll see this is the bigger axis, larger figure of figure axis 1, and now we'll plot figure axis 2. This is the smaller one, and we'll invert this so that you see that two different graphs are there and which graph is for which. This is the smaller one, and we're going to change this, and color, let's keep it as red to differentiate, and then plots will change, and 2, everything is set to 2. Now we've inserted the figure axis for 2, the smaller one, and there you go. Now we'll change this a little, so we'll call it x2, we'll call this y2, and this title 2, so that you guys can differentiate and see what's happening. So there you go. As you see that figure 1 was the bigger one, and that's outside, and you got title 1 up here and title 2 in here, and then this is how it's working. So I think this might have given you a basic idea. So now let's move on to subplots. The plt.subplots objects will act as a more automatic access manager. It will work on its own for you. So now if last time, as you remember, we tried to plot two different plots on the same canvas using functionality, right? So now we can do the same by subplots. So let's say this is how it will go. Oh wait, first I'll show you how to create a subplot and then go ahead with this. So it's the same thing. You'll start by saying fig and then axes equal to plt dot subplot, and there you go. Alright, and now use the axes object to add stuff and pick. So we'll go ahead with the same thing. We'll plot this only for now, and then we'll see. Axes dot plot. There seems to be some error. I don't know what seems to be error. It should have been okay. Maybe. Oh, sorry, I'm so sorry. There should have been an S in this. Sometimes something as basic as this could create an error. I am so sorry for this. There was a little error here. There was an S which was missing. That is why it was showing that error, and I didn't realize. So as you can see, yeah, we've got our graph now. This was the subplot method, and now we create two different plots. So for example, I'll copy paste this only. Yeah, okay. So now there you go. Now we want, let's say, the same thing which we had done earlier. So now you place the number of rows first. So now we're going to create from an empty canvas of 1 by 2 subplots. So over here, number of rows in rows equal 1, and then n calls equal 2. There you go. Now this will create two empty plots, right? Subplots. And now you can axis is an array of axes to plot on. So we're going to create axes, and Yeah, as you can see, it's an array. For now, we can iterate through this array, and we can plot the same thing on this particular array. So let's say for you all know for loops in Python, right? So it's the same thing for ax in axes. We're going to be careful of indentation over here. Plot, then we're going to plot in x comma y, and then we give it color red, and we're going to continue axis dot set. We'll set the label, or we could, you know what, we'll copy paste this, or let's make some changes to that. Or no, actually we'll go ahead with this only. We'll copy paste it to make it simpler for us. And be careful of indentation here. It needs to be you need to be careful because it's all under the for loop. And we change this. Okay, so now let's see our figure. Now let's see how fig looks. Okay, now you get two subplots. Wonderful. So now you got that idea of subplots, right? So this is simple, and now we use something known as plt.tight layout. Common issue with Matplotlib is overlapping of subplots or figures, so we use a fig.tight layout or plt.tight layout method, which automatically adjusts the position of axis on the figure canvas, so there is no overlapping content. Right now this is a small one, so you won't be able to see any issues like that, but later on with larger data you might have an issue. So you use this command plt.tight layout, and there you go. Okay, so sometimes it takes time to load. It depends on your computer speed. And okay, so till then, so now we'll move into the next thing: figure size, aspect ratio, and DPI. So yeah, okay, so there. Okay, cool. So now we'll move on to figure size, aspect ratio, and DPI. Matplotlib allows you to aspect ratio, DPI, and figure size to be specified when the figure object is created. You can use fig size and DPI keyword arguments. So fig size is a tuple of width and height of the figure in inches. DPI is dots per inch or pixels per inch. For example, I'll give you one example. Let's create fig equal plt dot figure, and we're going to keep fig size equal to, we're going to pass in a tuple of width and height. So figure fig size, let's say 8,4, and then DPI equal, let's say 100. Sorry, you don't have to pass it as a tuple, you could directly do that, and that's it, done. That's it. The same arguments can also be passed to layout managers such as subplots function. So in our earlier function also we could do the same thing. Subplot, and where is subplot? Okay, yeah, here. So we had, so we copy paste this down there. Okay, now in subplots also you could put in the same values, or let's say you want to just put fig size, which will give you the figure size, and we'll change it. Let's say, what values do you want to keep? Let's keep it as 12,3. 12,3. Great. So now you see that's how fig size works. Smooth. Up till now, I hope you guys don't have any issues. Okay, so now let's go ahead and learn how to save figures. MATLAB can generate high quality output in a number of formats, including PNG, JPG, EPS, SVG, PGF, and PDF. So we'll start by, it's a very simple thing. So we'll start by fig dot save fig, and we're going to put it in whatever file name, and let's say we want to save it as a png. Done. Here we can also automatically specify the DPI and choose between different output formats. So over here I could add DPI, and DPI equal to 200 or anything, and we could save this. And great. So now let's move ahead to legends, labels, and titles. So we already know how to set them, but let me tell you a little bit more about legends. In legends, you can basically choose where you want your legend to be placed. I'll show you an example. Okay. Okay, so here we go. So okay, now as you can see, we've already covered this. We've created a figure plot, canvas, and then axes. We've added axes, and to that plot we've added two graphs. Now x and x square, x and x cube, and then we've labeled them. And now legend. Now there are two separate lines defining what x square and x cube are doing. Now remember over here in the plot you'll also have to mention label, otherwise it will show an error. So this is that. And now coming to label, you could sorry legend, you can the legend takes function takes an optional keyword argument loc that can be used to specify where in the figure the legend is to be drawn. The allowed values of loc are numerical codes for the various places legends can be drawn. You could see the documentation pages for details, but for short I can tell you that it's from 0 to 10 for some of the, I'll tell you some of the most commonly used values. So okay, here, there you go. Okay, so these are the most commonly used values here. And uh, so one is upper right corner, two is left right, three is lower left, and four is lower right corner. There you go. Okay, and now you must be wondering why I've put 0 in this. So 0 automatically selects the best possible location for your legend. So over here it's already in a good position, right? So let's say I change it to, and we change this over here. Okay, now you see that it's overlapping, but now if I put loc to 0, it'll automatically choose the best position for the graph. That is the top left corner, which is perfect, and it's not hiding any particular data for us. Great. So this is a little bit about legends. Now let's come to the more creative aspect of Matplotlib, setting colors, line widths, line types, etc. So for that, I won't be taking more time on that. I'll just copy paste a set of data, and then from that only I'll show you. Okay, first, this might look very scary at first, but it's very simple, and I'll help you out step by step. So over here, you can, as you can see, I've plotted a subplot, figure size 12 and 12,6. Now in the first line, you can see the color is specified to be red, and the line width, you can constantly change your line width. So now you can see, I'll show you from the graph. I'll run this command. Okay, as you can see from here, there are four red colored lines and the line width is varying. So that's what, this is the line width command, and that's what it does. So now there are style options also. So for example, if you wanted a dotted line, or you wanted a dash line, or you wanted a dot dash line, there are a lot of variations possible in Matplotlib. And over here, these are the possible lines type. And uh, now you could also choose your marker symbols to be plus symbol, O symbol, star, S, numbers, anything. And you over here plus O, as you can see from 10, the blue colored lines, it's a square, O, Y, S, whatever, anything is possible. And then marker size and marker colors. Okay, so over here in the purple line section, you can see the marker is O, and the marker size has been increased, and marker color has been changed to red. So there's a lot of variations you can do with Matplotlib. It's a very beautiful software overall, and it's very interesting to code in Matplotlib. So for today, this is enough for Matplotlib. Now let's move on to Seaborn. Uh, okay, we'll take a 10-second break. If you guys have any doubts or issues, you can ask me in the comment section below. Okay, so let's begin. So, Seaborn is a statistical plotting library and it's built on top of Matplotlib. So, all that Matplotlib knowledge that we just learned is going to be really useful when learning about Seaborn. Seaborn has really beautiful default styles and it's designed to work really well with bounded data frames object. In order to get it installed into your computer, just type conda install Seaborn. So, conda install Seaborn. That's it. Okay, we're going to discuss different plot types with Seaborn that allow us to visualize the distribution of data set. Now let's get some data. Seaborn actually comes in with a few built-in data sets that you can directly load. I'm going to grab one called tips and save it as a data frame called tips. So over here, let's first we'll import Seaborn. Let's import Seaborn. Import Seaborn as SNS, and that's done. And we're going to do one more thing. We're going to set sns.set. Okay, so great. So now that I told you about inbuilt data sets, and so let's load one data set called tips. Okay, great. So now let's check out what tips is. So tips.head, if you remember from our last lecture, this is how you could go ahead and check it out. So okay, now let's see the various types of plots available in Seaborn. We'll start with distribution plots. So let's begin with dist plot. The dist plot shows the distribution of a univariate set over observations. Okay, so sns dot dist plot, and we'll pass in tips, and we will ask for the total bill. Let's say total bill. Great. There you go. As you can see, there is this graph. Now you must be noticing there is this other line graph also with this bar plot, right? Now this is the KD layer, and to remove the KD layer, just have the histogram. We just have to put in KDE.false. So we'll learn more about KDE in the upcoming lecture. So KDE we put it as equal to false, and now this is it. So now there won't be any, sorry, my bad, false with a capital F. Okay, great. So now you don't have that, and wonderful. Now it's working. So let's move ahead. Now let's move on to the next type of plot, joint plot. I'll be going fast because there are a lot of libraries, there are a lot of functions in this particular library, and it's a beautiful library to work with. So let's go sns.join plot, and x equal total bill, and put that, wait, I'm going to put it total bill, and y equal to, let's say, tip, and data set. We're going to keep our data is equal to tips, obviously, and you could put in, now in joint plot allows you to basically match up two dist plots for bivariate data with your choice of what kind of parameter to compare with. So now what a parameter you can put in a scatter plot, regression plot, KD plot, a hex plot. So now what do I mean by all of that? I'll show you. So that comes in kind. Now let's say I want scatter plot. Scatter. So now that's scatter. Okay. Joint plot. T is missing. Yeah, that'll work. Great. So now you see that data is scattered and it's according to total bill and tip. Now what I meant by other types such as regression, we'll learn more about regression in the upcoming series, but here's just about the graphs at least. So now you see that regression line, it's linear and it's perfectly in line with the data. So this is regression. You could also do a KDE plot. This shows you the density of the total bill and tip bracket. Okay, now I'll also show you hex. This is basically a very pretty way of displaying data. So these are a few types of in which you could display your data. So now let's move ahead and learn about pair plots. Now what pair plot does is it will give you a pairwise relationship across an entire data frame for numerical columns and support color hue argument for categorical columns. So let's call pair plot. So we call pair plot. All possible types will be compared in this. All columns will be compared. So we'll pass in tips, and this might take time depending on your computer speed, and but this data set is relatively small, so it won't take that much time. Okay, there you go. So as you can see, this has a comparison between total bill and all other three components, and where there is only one where it is compared only to total bill or tip is compared to tip, as you can see there's a simple bar plot histograms. Okay, great. So now in this pair plot, you could add hue, and hue could be used to differentiate between categorical data. What is categorical data? Basically types of data like male and female. So let's say we put in hue, and then we want to differentiate the tips by, let's say, the gender. So we pass in that, and we can choose the color palette also. So we're going to palette. There are various palettes available on the official documentation page. I would suggest that you go over that also. Today we'll use cool warm. Okay. Uh, Sorry, wrong spelling. My bad. Okay. Yeah. It'll take 1 second. Give it some time. Okay, there you go. So now you see this is basically a better way of representing data. You'll be able to see your data set better, and you'll be able to understand what's going on better. So this is one thing, and now let's move on to the next type of plots. We'll move on to the rug plot. Rug plot. So okay, let's see how this rug plots are actually very simple. It's a very simple concept. They draw a dash mark for every point on the univariate distribution. They're building blocks of a KDA plot. So this is basically a build up to KD. Let me just show you rug plot, and then we pass in tips, and in tips we want, let's say, total bill. Okay, there you go. Now after that, now let's move on to KDE plot. Now in KDE plot, KDR is basically kernel density estimation plots. The KDE plots are replace every single observation with a Gaussian normal distribution centered around that value. For example, I'll give you one code example. This is okay. Don't get scared by it. I'll explain exactly what is going on. Okay. Okay, cool. So I'm going to copy paste some code. I've copy pasted some code from the notebook, and you don't need to worry about understanding this code. It's just to build out a diagram for explanation. So I just have a few imports. I create a data set of random data. Then I use a rug plot on that random data over here. So I set up the x-axis for the plot. I use np linspace to create 100 equally spaced points from x min to x max, and then here. Okay, this is probably the hardest part to understand because it uses libraries we haven't used of. Okay, so that's not all. All this does is it plots normal distributions for each of the rug plot points, and that looks like this. We'll go ahead and zoom in on this. Wait, I'll run it, then let's go zoom in on this. Okay, so here, as you can see, this is what's happening. So we're just working on some random data. Notice I have blue dashes here, and these gray lines represent normal distribution. All right. So this is about our KDE. So now to get KDE plot. Okay, so now to get our KDE plot, we can sum these by functions, and there you go. Reduce the size back. Zoom out. Yeah, okay. There you go. Great. So this is about KDE plots and rug plots and distribution plots we're done with. Now let's move on to categorical data plots. So we load another type of data set for this. Let's go to actually, you know what? Let's continue with tips only. We'll continue with tips, and we'll continue with we'll start with, let's say, in categorical plots, we'll start with bar plot and count plot. So SNS dot bar plot, and then we're going to pass in, let's say, now x, we're going to pass x as sex and y as total bill, and data is obviously tips. Okay, there you go. That is a representation of the male and female total bill difference in the format of a bar plot. Okay, great. And now now we could put in an estimator, and you could use the NumPy library for standardization. So you could also do this, that in this particular set you could add an estimator. You can change the estimator object to your own function that converts a vector to a scalar. So let's see, estimator, we'll say np dot standard and as okay, great. So that's that. Now let's move ahead to count plot. This is an essential this is essentially the same as bar plot, except estimator is explicitly counting the number of occurrences, which is why we only pass the x value. So you could literally copy paste this much, and instead of bar plot, this will become count plot. And then we just need to pass in the x data, so gender, and then data equal tips. Alright, so now let's see. Great, so that's that. Now let's move on to box plot and violin plots. So now in this particular type of plots, we have, let's start. So box plot, and we'll keep x as the day, and we're going to keep y as the total bill. And then data is obviously from tips, and then we'll keep the palette as rainbow. Great, now let's see how this looks. So on Thursday the total bill was around this much, and this basically is a box plots or violin plots are used to show the distribution of categorical data. A box plot, or also known as box and whisker plot, shows the distribution of quantitative data in a way that facilitates comparison between variables across levels of categorical variable. The box shows the quartiles of data set, while the whiskers extend to show the rest of the distribution, except for points that are determined to be outliers using a method that is a function of the interquartile range. So that's that. And now what you could do is you could add in a hue, and you could see if the person who is paying the bill is a smoker or not. So it will give in the data set according to that. So we'll put in smoker. So if the person is a smoker, okay, so if this person is a smoker, it will have a different, over here you can see that. Now let's come to valent plots. SNS, actually, you know what, we'll copy paste this. Great. Okay, so we're going to change this. Okay, so we're done with the x. Our x variable is day, y is total bill. We're going to remove hue for now. Let me just show you the basic. And data is obviously from tips. Palette, we keep it as rainbow. Great. So now let's see. So this is more of a density kind of a plot. It shows you where there are where there is more concentration in the particular graph. So in this also you could put in your hue, and let's say you put in hue equal to, let's say, gender. Sorry, and let's go. So, and this basically shows you two different types of valent plots for male and female separately, and it's very simple. And now let's do something interesting. Now you see there are two different valent plots. Now I want to convert it into one particular valent plot. So now what I do, after this hue, I can add another quality split and put it equal to true. Great. Now you'll see something very interesting. Voila. See, that's another way of how valent plot works. It looks very pretty, and this is also another way you could use valent plots. So now we could go ahead and do strip plot and swarm plot. So we will just go copy paste that. So okay, we go first with strip plot. Okay, strip plot, x will keep as day, y is equal to total bill, data is equal to tips, and we remove this color palette. Alright, great. So now let's run that. So it gives you basically the different points at which there are, instead of having a box plot, now this will give you scattered points. So that's that. And yeah, I think we're done with this categorical types. Okay, and we could also see swarm plots. In this particular case, I'll just change this also. We'll go here, swarm plots. Okay, sorry, there's an extra P here. Great. Now you see, do you notice something in this, that you could, the valent plot and the swarm plot look very similar? And you know what? They have, they're very good. Now we can combine categorical plots, and for that, what you need to do is SNS, we copy paste the same thing under this, and let's see what happens. Magic. Woohoo. So now you see, now you can combine categorical plots. Now let's come to the final thing in categorical plots. We'll come to factor plot. Now in this, whatever we've learned, you could simply call it using a factor plot. So now how to do that, I'll teach you factor. You just type in factor plot, and you pass in x as whatever you have to, let's say gender, and then you have your y, let's say equal to total bill, total, let's go bill, and yeah, okay, and data, let's say data is equal to, data is obviously tips, data is tips. And now here comes the interesting part. Now you can specify the kind of plot you want. Let's say you want a bar plot, there you go, there. Now you could have a bar plot, you could have all the types of plots. Factor plot is the most general form of a categorical plot. It can take in kind, parameter, to adjust the plot type. You could have a violin plot, you could have a box plot, swarm plot, any plot using factor plot. So yeah, that is that, and now we're done with that. Now let's move on to the next part. Let's move on to matrix plots. Matrix plots allows you to plot a data as color encoded matrices and can also be used to indicate clusters within the data. So let's import a new type of data set. Let's go with flights equal sns dot load dataset, and we call it flights. Great. Okay, wonderful. Okay, now we already had tips. Now we're going to check tips dot head once more because it was way back. Okay, great. Now we'll check flights head. Great. Okay, now that's done. Now let's start with the heat map. So you need matrix form for correlation data. So let's get tips dot corr. Now this gives you correlation data, and now run that. Now let me show you what a heat map is. So this is a heat map, sns dot heat map. Heat maps are extremely useful. Heat map, and then you pass in tips dot corr. Let's say tips dot corr, and then yeah, wonderful. Okay, so this will give you, okay, wonderful. So now this will give you your data. You could also put in the value to see the value of instead of colors. You could, inside the colors, you can add and not equal true. Now not just colors, you also have the values inside them. You could also choose your color palette. Let's say CMap equal cool warm. There you go. All right. So the warmer it gets, the redder it gets, basically the higher it is, and the bluer it is, the lesser it is. That goes towards 0.5. So yeah, great. So now you know about uh, basic heat maps, and uh, let's learn a little bit more. Which we could take in a few more examples. I feel flights dot pivot table. I'll show you the table first. Of pivot table, and okay, let's see, we want values of passengers, and we want our index to be month, and columns to be year. Great, let's see that. Oh god, values. Okay, great. So that gives you your data, and now let's put that into a heat map. So we'll call it PV flights, and we'll put it equal to all of this. And we'll call a heat map based on this, sns dot heat map, and we're going to pass in PV flights. Great. So basically now you can see that more number of people are traveling between July and August from this data set. Also you can see, so this is for American flight data, which is pretty old, 1960, 1949, from 1949 to 1960. So yeah, that you could change colors and then have your own set of if you don't like this particular setting in which you don't see the distinction between columns, so you could add in a line width section. So now line width, you'll see a white line in the middle. You could change the color also, but let's say you keep the line width as 1. My bad. Line width S, there will be an S here. Oh, sorry, I'm passing it in the wrong place. I'm so sorry. Wrong place I was passing it. So over here in the heat maps, you'll have to pass that. Okay, so now you get your white lines here. So that's about that, and we're done. Now you can see if you want to use now if you want to see more clustering to check out clustering the cluster map, you can use see a cluster map. The cluster map uses hierarchical clustering to produce a clustered version of the heat map. For example, I'll show you one SNS. Sorry. Okay, yeah, SNS dot heat map. Sorry, SNS dot cluster map, and then we put in PVF lights, and then it basically collects the data which is similar to each other. So it sort of groups the data. So yeah, that's about it, and this is the basics about our matrix plots. And now let's move on to something different. We'll move on to grids. So I just wanted to show you what pair grid does. So it's just to visualize your data a little bit better. Pair grid, and then let's say you pass in tips. Sorry, this G is also capital. There you go. Okay. Remember from pair plot we had three different distinctions. So this is basically the pure canvas and what all is the possibilities. You could add in a scatter plot or do whatever to this. I'll not delve into this because it takes a lot of time. This is another type of way you could use your pair plots. We already covered that, so I'll not go into it again. So let me tell you a little bit about regression plots. We'll be covering regression later on, but just giving you a intro into regression. Seaborn has many built-in capabilities for regression plots. However, we won't really discuss regression until machine learning section of this course. So we'll only cover the lm plot function for now. So let me just show that. Go ahead and show you the lm plot. Okay, this is the lm plot. Sorry. SNS dot lm plot, and we put in. Sorry, yeah, x equal to, let's say, total bill, and over here let's say y equal to tip, and data equal to tips. Okay, so that's the basic regression plot. And now in this you could have hues, define different types. So we could have a hue, let's say gender, and according to different genders, there you go. And yeah, you could also change the markers. In this you could specify markers and then change it. And yeah, this is about it. This is about regression plots. So hope you had a fun time, hope you got something new to learn. And if you have any doubts, you can use the comment, you can comment down below, and I'll be happy to help you out. Thank you so much. This has been my time, and a huge shout out to Shubham and SIAM VIT for making this possible. Thank you. Love you. See you all next time.